Hello everyone, welcome to our channel Coders Arcade. Before starting our video, I would like to request you to please like our videos and subscribe to our channel and press the bell icon so that you receive a notification of our latest videos. So let's start.
So in today's video, we are going to talk about operators in C. So what are operators? I'm pretty sure that we all are using operators on a daily basis in our day-to-day lives. Let me give you an example. Suppose you are in a shop and you are buying some items. Now you are going to pay for those items to the shopkeeper. Now suppose the total is 475 bucks, but you give the shopkeeper 500 bucks. And now you start calculating in your mind that how much you will be getting back from the shopkeeper. So while you are thinking, you are doing some mathematical operations in your mind. Those operations are done by operators. In this case, operator is minus and the operation is subtraction. So basically, you are thinking here what amount you will be getting back. Similarly, there are many operations in our day-to-day lives, such as division, multiplication, addition, and so on. There are many more operations that we use. Similarly, in C programming, C supports a rich set of built-in operations. So basically, an operator is a symbol that tells the computer to perform certain mathematical or logical operations. Operators can be used in program to manipulate data and variables. Symbols like plus, minus, multiplication, division, all of these symbols are operators. So now let's see how many types of operator we have in C. So C operators can be classified into the following types. Here you can see the first one is the arithmetic operators, then relational operators, then logical operators, then bitwise operators, then assignment operators, the conditional operators, and the special operators. So let us look all these operators one by one. So first one is the arithmetic operators. So what are arithmetic operators? Arithmetic operators are basic operators such as plus, minus, multiplication, division, and modulus. So let us see what all these operators do. So the plus sign here adds two operands. So if we write like 1 plus 1, then 1 and 1 on both the side of this operator on this plus sign are the two operands, and this plus sign is the operator. So what this operator will do will add two operands. Similarly, this minus sign, this minus will subtract second operand from the first. So suppose a minus b, so b will be subtracted from a. Then similarly star. In C, star represents the multiplication. This is the star operator or the multiplication operator. So this will multiply two operands. Now comes the forward slash or the division operator, which is used in C to divide numerator by denominator. So in this case, this operator will divide numerator by denominator in simple fraction. Then comes the modulus operator. This modulus operator gives the remainder of the division. Now suppose this division operator divides the numerator by the denominator. But this modulus operator, what it will do is the remainder which is left by dividing numerator by denominator, that remainder will be fetched by this modulus operator, and this will give the remainder of that particular division. So these are all the arithmetic operators. Now let's go on to the second type, which is the relational operators. So these are all the relational operators. So let's check all of these one by one. So first one is double equals. So what this double equals does is it checks if two operands are equal. That means suppose here we write a double equals b, then it will check if the b has the same value as a. Then comes the second operator, the second relational operator, which is exclamation equals. This means not equals. So what this operator will does is checks if two operands are not equal. Then comes greater than operators. So what it does is it will check if the operator on the left is greater than the operator on the right hand side. Similarly, with this smaller than operator, so this has the opposite of the greater than. So this will check if the operator on the left side is smaller than the operator on the right side. Then comes the second last relational operator, which is greater than equal to. So this will check if the left operand is greater than or equals to the right operand. And similarly, smaller than equals. This will check if the operand on the left is smaller than or equals to the right operand. So these are all the relational operators in C. Let's move on to the other type, which is logical operators. So C language supports following three logical operators. Now suppose value of A is 1 and value of B is 0. Then the first operator here is double ampersand or ampersand ampersand, which means logical and. Here in this case, let's see an example. A ampersand ampersand B is false. What this means is, why is it false? Because value of A is 1 and the value of B is 0. Logical AND means both the values should be same, otherwise it will give us false. So since here value of A is 1 and value of B is 0, so that is why the value is false. Now suppose if the value of B becomes 1, then this value will be changed to true, because now A is 1 and B is also 1. That is why this will give us true. But in this case, since A is 1 and B is 0, both the operands doesn't have the same value. That is why it is giving us false. So in the case of logical AND, both the operators should be same, then only it will give us true, otherwise it will give us false. Then comes the next operator, which is the OR operator. So OR operator is made by writing two pipe symbols. So this single line is called pipe symbol. So if you write double pipe, then in C it will become logical OR operator. So what the logical OR operator does is, it checks if any of the operand value is true, then this will come true. So here in this case, as you can see, value of A is 1 and the value of B is 0. So in this case, A or B is true. Why it is true? Because here the logic behind this is OR means any of the operand value should be true. In this case, we have A is equals to 1 and B is equals to 0. It doesn't matter that A should be 1 or B should be 1. It can be 1 or 0, or A can be 0 and B can be 1, or A can be 0 and B also can be 0. If any of the value is 1, then it will give us true. So this is what OR does is. Now comes the third logical operator, which is the exclamation mark or the logical NOT. So what this logical NOT does is, it will negate the value. So in this case, since A is 1, NOT of A is false. That means NOT of A means this value is negated. That means now after using a NOT operator with A, it will negate the value and it will change the value of A from 1 to 0. That is why it is coming false. If the value will be 1, then it will give us true. But here, since the logical NOT is negating that value, it will give us false. So these are all the logical operators in C. Now let's move on to the other operator, which is the bitwise operator. So what this bitwise operator does is, bitwise means bit by bit calculation. So bitwise operator performs manipulation of data at bit level. These operators also performs shifting of bits from left to right. Now note that bitwise operators are not applied on float or double. So let us see these operators one by one. So this is one single ampersand. This single ampersand means bitwise and. As in the logical operator, we were using double ampersand, that means logical and. Here in bitwise operators, we use single ampersand to represent bitwise and. Similarly, the bitwise or. Here in logical operator, we were using double pipe sign, that was representing logical or. Here in case of bitwise operator, single pipe means bitwise or. And then this cap symbol that you are seeing here means that is bitwise exclusive or operator. Here in this case, basically it's the same as the not operator that we talked about earlier in the logical operator, that is the logical not operator. Here in this case, it is represented as cap and it is called bitwise exclusive or. Then comes the left shift operator and the right shift operator. So the left shift operators is represented by this symbol, which is smaller than, and the right shift operator is represented by greater than symbol. So these two, left shift and right shift operators, will be talking about these two operators in our future videos in our advanced topic. So stay tuned to our channel Coders Arcade and like, share and subscribe to our channel and press the bell icon as well so that you'll get notified when I post the video about left shift and the right shift operators. So now let's understand all these bitwise operators with the help of truth table. So this is the truth table for bitwise and bitwise or and the bitwise exclusive or. So here, this is the values of A and this is the values of B. And here we are performing operations such as A ampersand B, which is the A bitwise and B, and A bitwise or B, and A bitwise exclusive or B. So let's first see about bitwise and operator. So here, if the value of A is 0 and the value of B is 0, then if we do bitwise and, then it will give us 0. If the value of A is 0 and the value of B is 1, then it will give us 0. If the value of A is 1 and the value of B is 0, then again it will give us 0. And if the value of A is 1 and the value of B is 1, again it will give us 1. So while performing A bitwise and B, 0 0 means 0, 0 1 means 0, 1 0 means 0, and 1 1 means 1. So this is the A bitwise and B. Now if we talk about A bitwise or B, here in this case, if the value of A is 0 and the value of B is 0 as well, then we'll get 0. If the value of A is 0 and the value of B is 1, then we'll get 1. If the value of A is 1 and the value of B is 0, then we'll be getting 1. If the value of A is 1 and the value of B is 1 again, it will give us 1. So basically, while we do A bitwise or B, then 0 0 means 0, 0 1 means 1, 1 0 means 1, and 1 1 means 1. Now let's see A bitwise exclusive or B. In this case, if the value of A is 0 and the value of B is 0, it will give us 0. If the value of A is 0 and if the value of B is 1, then it will give us 1. Again, if the value of A is 1 and the value of B is 0, then it will give us 1. And if the value of A is 1 and the value of B is 1, it will give us 0. So in this case, A bitwise exclusive or B means 0 0 will give us 0, 0 1 will give us 1, and 1 0 will give us 1, and 1 will give us 0. So this is the truth table for all the bitwise operator. For the left shift and the right shift, as I told you before, we'll be covering those two bitwise operators in our future videos. So stay tuned for that. Now let's move on to the next operator, which is conditional operator. So here conditional means if-else statement that we generally use in our programs. But here, with the help of conditional operator, you can eliminate the whole if-else statement, and instead of writing if-else statement, we can write the whole if-else statement in one single line. So this is the syntax for the conditional operator. So syntax is question mark and colon. So just before question mark, we write our first expression here. After the question mark, we write second expression here. And after the colon, we write the third expression here. So as you can see on the left hand side, I have written a small program, and then by the help of conditional operator, this conditional operator, I have written on the right hand side, I have written another program which is the same program as the left hand side program. So I have written here int marks. So here I have declared marks as int. So this marks variable will only be able to carry integer numbers into it. So int marks. Then I have used the conditional statement if else. So I have written if marks is greater than 33, then it will print pass. Otherwise, it will print fail. So we can eliminate this whole if else statement with the help of conditional operators. As you can see here, I have written char result. So I have declared a variable result which is the data type char, which means characters. So now result will be able to hold only character type, which is pass or fail. Then I have taken another variable called marks, which is int, so that it can house this value 33 into it. So I have written here, instead of using if else statement, I have written result, this result equals marks greater than 33. This is our first expression here. Before question mark, this is our first expression. So this tells us that this is the first condition. So if marks is greater than 33, then after the question mark, it will print pass. Otherwise, it will print fail. So this colon here represents the else block, and this question mark represents the if block, and this expression 1 here represents our condition. So this means that if marks is greater than 33, then it will print pass, same as here. Otherwise, else it will print fail. Else it will print fail. So this is how you can use conditional operator. So now let's move on to our other operator, which is the assignment operator. C supports following types of assignment operators. So our first assignment operator is equals operator. So what it does is it assigns values from right side operand to left side operand. That means if I write A equals B, now suppose B has a value 20 and A is empty, A doesn't have anything inside it. So if I write A equals B, that means if B is 20, then this value, this 20 value will be carried to A. So now the value of A is also 20. So if I write A equals B and the value of B is 20, then A will also become 20. Then our next operator is the plus equal sign. So what this does is it adds a right operand to the left operand and assign the result to the left. That means if I write A plus equals B, it is same as writing A equals A plus B. So instead of writing A equals A plus B, you can use this operator, which is plus equals, and write A plus equals B. So this will improve the efficiency of our program and reduce the repetition of our code. Again, similarly, minus equals. Now this again means subtract right operand from the left operand and assign the result to left operand. That means A minus equals B is the same as writing A equals A minus B. Similarly, multiply equals or star equals. So what it does is it multiplies left operand with the right operand and assigns the result to the left operand. So again, we can write, instead of A equals A into B, we can just write A star equals B. So it is same as writing A equals A into B. Then our next operator is forward slash equals. That means divide equals. So what it does is it divides left operand with the right operand and assigns the result to left operand, which means A divide equals B is same as writing A equals A divided by B. So instead of writing A equals to A divided by B, we can just simply write A divide equals B. Then comes our next operator, which is modulus equals. So what this modulus equals does is it calculates modulus using two operands and assign the result to left operand. So again, this means A modulus equals B is same as writing A equals A modulus B. So instead of writing A equals A modulus B, we can just write A modulus equals B. So with the help of these operators, we can reduce the repetition of our code and increase our efficiency of our program. So this is all about assignment operators. So let's move on to our next last operators, which are the special operators. So now C supports three special operators. The first special operator is size of. So what it does is it returns the size of an variable. That is, this is the syntax of size of. So we write size of, let's say our variable is x. So we write size of, then in parentheses we write x. So what it does is this will return the size of the variable x. Now next, ampersand sign. Now this ampersand sign in special operators, what it does is it will return the address of an variable. So this is the syntax of writing this special operator, which is ampersand x. So what it does is it will return address of that particular variable, which is x. So for example, x has a value 5. Now, where this x equals to 5 is saved on our computer, it will give us the address of that particular memory location in our computer. Next, star operator. So in special operator, star means pointer to a variable. That means if we write star of x, then it will give us the pointer to a variable which is x here. So this pointer here is a very advanced topic that we will be covering in our future videos. So stay tuned for that. So now you just need to know about this star special operator. So what it does is it will give us the pointer to a variable. So this is all about the operators in C language. So in this video we covered about arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators, conditional operators, and special operators.
And we have already created a comparison video where we have told the topics which were missing from the old scheme and those topics which are new into this particular new scheme that is being followed in VTU. So this video is going to be part of that scheme only. So there is one topic in C programming that we are going to see as a new topic, and that is typecasting. So typecasting was not there in our old scheme and it is there in our new scheme. So let's talk about typecasting in C programming. Now, before I start this video, guys, I would like to request you people to please like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon so that you won't miss any future updates. So now without any further ado, let's get right into the topic, guys. So right here, as you can see, I have written two programs for you guys. One is demos.c and the other one is demo1. So in this case, if you see that, I have written both C programs only in both of them. So the typecasting. First, learn about what is typecasting. Typecasting is the process of conversion of one type to another type, one data type to another data type. In this case, we are talking about conversion of any data type, for example, int to float or float to int or any other data type. Now, there are basically two types of type conversion, implicit type conversion and explicit type conversion, where implicit type conversion are those type of type conversions which happens to be automatically done. We don't have to do any type conversion explicitly or manually. In the case of implicit type conversion, the types get converted automatically from one type to another type. And this generally happen from smaller data type to a larger data type. Now, for example, or maybe it depends. Like it depends. Totally, it depends upon language to language. So in this case, we are seeing the type conversion or type casting happening from int towards float or int towards character, and we'll see how it is going to work actually. So in this case, implicit typecasting is the typecasting which happens to be automatically done by the program itself. So we don't have to worry about it. For example, let's see. Here we have taken a short type of variable, short x equals to 200. And in this case, we are saying int y equals to x. So basically, I took x and I put it inside y. So this way, I just, you know, took the value and put it inside integer type. So short value came into integer type. So, well, this is one type of typecasting that you can do. Like this will happen automatically. Now x, which was 200, got converted from short to a integer type. So from smaller type to a larger type happens to be automatically done. So, well, you won't see any much difference here. Well, everything will be printing as 200, 200 only. But in this case, if you see in this example from line number 11, I've taken a integer variable num and which is going to be set to 20 here. And I've taken character ch equals to small a. Now, if I say here, I took another third variable called result of integer value, and then I said 20, this 20 plus small a. So here a is equivalent to 97. Here a will get automatically converted from the character type to an integer type and will get added here, which will be equivalent to this 97. So 97 plus 20, it will come as 117. So here you can see that when I'll run this program, you will see that I'll run this program and I'll show you. I'll run this program. So this 200, 200 are coming from these two values. Okay. And this 117 is getting coming from a to 20, like a plus 20. You got my point what I'm trying to say, where a is here equivalent to 97. 97 plus 20, it becomes 117. Now, if you see here, float val, and then I'm adding this 20, which is stored inside this num, plus capital A. Here, capital A is equivalent to 65. That means now 65 plus 20, it will become 85. And now because I've taken a float value, I'm printing it as percentage %f and I'm printing the val. So it is gonna print 85 point this. So here you can see that here this A also got automatically translated from character to its equivalent ASCII value to 65. And this is how this process of getting converted from one type to another type automatically, in this case here, character got converted into integer automatically, and this is going to be called as implicit type conversion, where implicitly the types are getting converted from one type to another. So this is implicit typecasting, guys, and this happens to be automatically, as you can see in this example. Now let's move on to explicit typecasting. So explicit typecasting, what is explicit typecasting? So if I told you that implicit typecasting is happening automatically, explicit typecasting on the other hand will not happen automatically. Here you have to come and then manually convert the types from one type to another. And that is the reason why we call it as explicit typecasting. In explicit typecasting, when the values are not able to get converted automatically, you have to convert them. For example, I've taken here two variables into a and b and the third variable as result, and I have taken it as a float. Now if you see that a equals to 25 and 21 and b equals to 5, now if I divide them, you can see that the result will come, it loses some information. So there is one chance of losing information here, guys. In explicit type conversion, there are chances of losing the data, not every time but in some scenarios. One scenario is here. So when I run this program, you see that actually 21 divided by 5, it should be 4.2. But actually when you print it directly, because both the numbers were integer only, when you will divide it, it will only print 4, as you can see in the output. Point 2 is deleted in this case because it did not convert it automatically to a float value. Computers are not that smart, and that too, C programming, this is the place where you have to do explicit typecasting from integer to float, because here 4.2 cannot be achieved using these two integer numbers. And that is the reason here you now need to apply explicit typecasting. So to apply explicit typecasting, this is the way we apply explicit typecasting. We use this cast operator. Now when you say parenthesis open close, sometimes in terms of typecasting we say it as cast operator to convert the int data type or any data type to any data type. What you need to do is just before you do that, before you do the division or whatever, you write this in front of it, like just before it. And then you store it in. Now result was also a float type of value. So when you divide it, first it gets converted to float and then it is getting stored into this result. Well, now this time it will print that particular type of value. So 4.2, now it's a float value. Now this process which I'm highlighting right now is the way that you do explicit typecasting. I hope so that you understood this very well, guys. And this is the two types of typecasting that I wanted to show you. One is implicit typecasting and another one is explicit typecasting. And this is a very small topic and it is very easy to understand also. If you have any doubts, you can ask me in the comment section below. I'll explain you there and I'll try to clear your doubts as much as possible. And that's it for this video, guys. Thanks for watching and that's it.
Hello everyone, we will be discussing the next topic, which is decision making and branching in C language. So before starting the video, I would like to request you people to please like our videos, share it with your friends and family and press the bell icon so that you receive a notification of our latest updates. Thank you. So let's start with today's topic. So what is decision making and branching? Decision making is about deciding the order of execution of statements based on certain conditions or repeat a group of statements until certain specified conditions are met. C language handles decision making by supporting the following statements, which are the if statement, the switch statement, the conditional operator, the goto operator. So these are the four types of decision making statements used in C, as I told you. As you can see here, these are the if statement, the switch statement, the conditional operator statement, and the goto statement. These statements are popularly known as decision making statements. Since these statements control the flow of execution, they are also known as control statements. We have already used some of these statements in the earlier examples. Here, we shall discuss their features, capabilities, and applications in more detail. So let us start with the first one, which is the if statement. So the if statement is a powerful decision-making statement and is used to control the flow of execution of statements. It is basically a two-way decision statement and is used in conjunction with an expression. It takes the following form or syntax, as you can see here. If test expression. It allows the computer to evaluate the expression first and then, depending on whether the value of the expression, relation or condition is true or false, it transfers the control to a particular statement. This point of program has two paths to follow, one for the true condition and the other for the false condition, as shown in the figure. As you can see here, there is an entry and then you have the test expression. If the expression is false, then it follows the false path. If it is true, it follows the true path. This is called the two-way branching. Some examples of decision making using if statements are as follows. If bank balance is 0, borrow money. Then if room is dark, put on lights. If code is 1, person is male. Or else if age is more than 55, you can take any other number. Age is more than 60, person is retired. So the if statement may be implemented in different forms depending on the complexity of conditions to be tested. The different forms of the if statement are the simple if statement, the if-else statement, the nested if-else statement, and the if-else ladder. We shall discuss each one of them in the next few minutes. So let's start with the simple if statement. The general form of a simple if statement is if test expression, then the statement blocks, then after that statement X. The statement block may be a single statement or a group of statements. If the test expression is true, the statement block will be executed. Otherwise, the statement block will be skipped and the execution will jump to the statement X. Remember, when the condition is true, both the statement block and the statement X are executed in sequence. This is illustrated by this flowchart. So you can see here, we have the entry, then the test expression, and it follows two paths, true and false. If it is true, it will execute the statement block, then it will go to the statement X. If it is false, it will directly go to the statement X. Then it will go on to the next statement. So let us look at an example where we will be knowing about the if statement more. I will go to my editor now. So here you can see in my editor, I have already written a program for you, and I have included the standard input output library by writing this hash include stdio.h. Then this is my main function, and here I have declared four variables which are integer data type, and I have taken another variable ratio which is of the floating data type. Then I am asking the user to input this four integer values, and then I am taking the user input by using the scanf function. Then what I am trying to do is I am trying to calculate the ratio. When I am calculating the ratio, I am doing it when the value of c minus d is not equal to 0, because if c minus d is 0, then you cannot divide any number with 0. So I am giving this if block, and here I am taking the condition c minus d not equal to 0. Then if it is true, then it will calculate the ratio like this. It will calculate a plus b, and then it will calculate c minus d, and then it will divide a plus b by c minus d, and finally it will print the ratio. If c minus d is not equal to 0 or this statement is false, then it will do nothing. It will just go out of the program execution. So I will run it for you and show it to you. The shortcut is F9. I am pressing it. So I will just zoom it for you so that you can see it better. Now it's visible. I will give four numbers. You can see I am giving 1, then 2, then 3, and then 4. So if I press enter now, the ratio will be calculated, because you can see 3 minus 4 will be minus 1. So it is not 0. It will calculate the result. I am pressing enter. And here you can see the ratio comes in minus, because 3 minus 4 is minus 1. And we are getting the answer as minus 3.0, because this is float. So the program is working correctly. And I will press enter once again. I will show you the alternative part where this thing will not work. So I'm pressing F9 once again to run it. And here you can see I will zoom it once again. Now I will provide the values again. Say 1, 2, and 3. This is C. And for D again I will give 3. So 3 minus 3 will be 0. And now you can see it will not print the ratio. I'll press enter. And now you can see it finished the process, but it did not give any output. So this is a simple example of the if statement. I'll press enter. So here you can see only when this condition is true, then it is executing this part of the code. Otherwise, it is simply going out of the execution statement and it is ending the program. So now I will show you another example of the if statement where we will be using a compound operator. So here you can see this is another program where I am using the if statement but with the compound operator. What I am doing is I am trying to calculate the number of boys who have their weight less than 50 and who have their height greater than 170. So to combine them, I am using this line of code, and here you can see this and. This is the AND operator. So what it will do is, if both these conditions are true, only then it will increment this count by count equal to count plus 1. So I will explain the whole program line by line. Here we can see this is the count variable and the I variable, which are integer, and I have the weight and the height. Then I am initializing the count to 0, and I am taking this print statement where I am telling the user to enter the weight and height for 10 boys. And here you can see I am using a for loop, and then I am asking the user to input the weight and height. And after a single value is provided, I'm incrementing the count to count plus 1. So as soon as we will be getting any one boy weight less than 50 and height greater than 170, this count equal to count plus 1 will be executed, and this count equal to 0 value will be incremented. So like this, we will be getting the number of boys who have weight less than 50 and also height greater than 170. So this 50 is in kg and this height is in 170 centimeters. So after that, I am trying to print the number of boys with weight less than 50 and height greater than 170, and with the help of this count. So this count will be incremented and we will be getting the result. So now let me show how it works. I will run it for you. I'm pressing F9, and you can see, let me zoom it for you. It says enter weight and height for 10 boys. So I will give, say, 45 and space 172, enter. I will give many other values, 36, 150, and I will keep on giving it 170. So now you can see I have given 10 weight and height values for boys, for 10 boys, and you can see all these values here. So my condition was less than 50 kg and greater than 170. So this one satisfies it, and again I will show you which one satisfies it. And I guess I gave only one value which satisfies this condition. So now if I press enter, you will be finding the number of boys who have their weight less than 50 and height greater than 170. I'm pressing enter, and you can see number of boys with weight less than 50 and height greater than 170 is 2. So let us check in our data. Here you can see I missed it out. You can see the first one is 45 and 172. This satisfies, and this is 39 and 182. This as well satisfies. So we're getting this count equal to 2. So this is how this program is working. I'm pressing enter, and this was an example of an if statement where you can use the compound and operator, and then you can put an expression in the if block and you can execute it. So now let us move on to the next one, which is the if-else statement. So the if-else statement is an extension of the simple if statement. The general form is, as you can see in the diagram, if test expression, true block statements, else false block statements. Then finally the statement X. So here, if the test expression is true, then the true block statements immediately following the if statements are executed. Otherwise, the false block statements are executed. In either case, either true block or false block will be executed, not both. So whichever is true will be executed. This thing is illustrated with the following flowchart. In both the cases, the control is transferred subsequently to the statement X, as you can see in the flowchart here. So here you can see, for the test expression to be true, it goes to the true block statement and then to the statement X. If it is false, it goes to the false block statement and then to the statement X. Let us take a small example so that we can understand more about this if-else statement. I will go to my editor now. So here you can see I have already written a program for you. This program actually checks whether a number is even or odd. So here you can see I have taken an integer data type variable which is number. Then what I am doing is I am using the print statement to print this in the console or the terminal, and then I am taking the user input, which is the number. Then I am checking with the help of 2. So definition, according to the definition of even numbers, if it is divisible by 2, then it is a even number, or else it is an odd number. So here, if the number is divisible by 2, you can see I am using this mode operator. So this will give the remainder. So that means if number is divided by 2 and the remainder is 0, then it is an even number, or else it is an odd number. So here, after this statement is checked, if it is true, then it will print it is an even number, or else it will print it is an odd number. So let me run it so that you can understand. I'm pressing F9, and let me zoom it for you so that you can check. I am putting the number 9. So this is an odd number, right? If I press enter, you can see it displays the number is odd. So the program is working perfectly. I will try to show you the even one also. Let me press enter and I will run it again. And let me zoom it for you. Say I press 4 and press enter. So you can see the number is even. So I showed you how to use the if-else statement here. And in this case, I am checking whether a number is even or odd by using this program. So you can do many more things with the help of this if and else statement. So now let us move on to the next topic, which is nesting of if-else statements. So when a series of decisions are involved, we may have to use more than one if-else statement in nested form as shown in the diagram here. So you can see in this diagram, if the condition 1 is false, the statement 3 will be executed, otherwise it continues to perform the second test. If the condition 2 is true, statement 1 will be evaluated, otherwise the statement 2 will be evaluated, and then the control is transferred to the statement X. So let us check a flow chart so that we can understand more about this nested if-else statement. So here you can see when the test condition 1 is true, then it goes to the test condition 2, and again it will check the test condition 2. If it is true, it will go to statement 1. If it is false, it will go to statement 2. Then finally, it will go to statement X and then to the new statement. But initially, if the test condition 1 is false, it will directly go to statement 3 and then it will go to statement X and then to the next statement. So this is how it becomes very easy to understand the flow of the nested if-else statement. So let us check an example so that we can know and understand the nesting of if-else statements in a very good way. I will go to my editor now. So here you can see I have already written out a program using the nested if-else statement. Here what I am trying to do is I am taking an user input of 3 numbers and then trying to print the largest of the 3 numbers. So let me show you what I have done here. You can see I have taken 3 variables A, B and C which belong to the floating data type. Now I am taking the input from the user and then I am printing the largest number is, then here you can see this is the entire condition. Here I have used the nested if-else statement. You can see if A is greater than B, then it will go into this block. You can see here. After A is greater than B, if it is true, then it will check if A is greater than C. Then finally we will be ending up with the conclusion that A is greater than both B and C. Therefore, it will print A as the greatest number. Else it will print C as the greatest number. Or else, if this condition is initially false, then we can assume that B is greater than A. Then we will check B with C. So if B is greater than C, then it will print B, or else it will print C. So this is a simple logic behind the program here, so that we can get the largest of 3 numbers. I will just run it and show it to you how to use it. I'm pressing F9. and let me zoom it for you. So here I will give three numbers, say 5, then 6, and then 4. You can see I got the output. The largest number is 6. It is coming in 6 point this decimal digits because I took it as a floating point value. So the program is working correctly, and out of 5, 6 and 4, 6 is the largest. So I'm getting the answer correctly. I'll press enter and let me check it with any other values. I will run it again and let me zoom it for you. I will take 12, press enter, 13, press enter, then I will take 0, 2, press enter. Then you can see out of these three numbers, 13 is the greatest. So it's printing this. The largest number is 13. And this decimal points is because I have taken the floating point data type. So this program is working perfectly. I press enter. And here you got to see how to find the largest of three numbers using the nested if-else statement. So here you need to be very careful regarding the indentation, because otherwise you will get confused. If I had written all these if-else statements in the same line, you would have got confused. That's why to properly demonstrate the use of the nested if-else statement, I have used this indentation. You can see there is a space between this. So in order to make your program look good and to make people understand how you were utilizing your source code, it's better to provide indentation. You can do it without using indentation also, but I suggest you use indentation so that your code looks better and it is very easy to understand. So now let us move on to the next topic, which is the else if ladder. Here, what happens is, if you have more than one condition, or to be precise, I can say if you have more than two conditions, and it may go on to say maybe 5, 6, 7 conditions. In that case, we will be using the else if ladder. It becomes very easy to execute the flow of the conditions with the help of this else if ladder. You can see the general syntax of this else if ladder here. So here you can see the if statement has the condition 1 and the statement 1. Then the else if has the condition 2, statement 2, and similarly it will go on. And finally, the final else statement will have the default statement. And then after all, it will give the control to the statement X. This construction is known as the else if ladder. The conditions are evaluated from the top of the ladder downwards. As soon as the true condition is found, the statement associated with it is executed and the control is transferred to the statement X, and it will automatically skip the rest of the ladder. But when all the n conditions become false, then the final else condition, which contains the default statement, will be executed. So let us check a flow chart where you will understand better about it. So here in this flow chart, you can see it will initially check all the conditions, condition 1, condition 2, condition 3, condition n, and whenever it finds the true condition, it will give the control to the statement X. And in other case, whenever all the n conditions are not true, it will execute the default statement and then it will give the condition to statement X. And finally, it will go to the next statement. So this is a beautiful way to understand about the else if ladder. And let us take an example in our editor so that we will understand more about this else if ladder. So here you can see this is the use of the else if ladder. Here we have taken many conditions. You can see what I have done actually in this program is I have initialized a variable I which is of the integer data type and taken the value to be 50 here. And then I am using the else if ladder. First I am checking if the value of I is 50, then it will be printing I is 50. Otherwise, it will go to the next condition. It will check if I is 55, it will print I is 55, or else it will go to this line where it will check I is 60, it will print I is 60. And finally, if all these three statements are false, then it will continue to the else statement where it will print the default printf statement, which is I is not present. So as I told you in the flowchart, it checks all the conditions and finds the true condition, and then it goes to this end of the program. Here in this case, it will try to execute all the statements. If none of them are true, then it will print the default statement. But in my case, I have taken I equal to 50, and this first if statement is actually true. So let me run it so that you can get an idea. I am pressing F9, and here you can see I am getting I is 50 because you can see the I value is 50. So let me change it. I will change it to 20, and then I will run it again. I will press F9. Here you can see as soon as I change the value of I to 20, it says, I will zoom it, let me zoom it for you. I is not present. So this is a basic example of the else if ladder. You can do many more operations with the help of this else if ladder. So as I told you, if you have more than two conditions, you can use this method and you will be able to sort out the flow of your output. So let us move on to the next topic, which is the switch statement. So we have seen that when one of the many alternatives is to be selected, we can use an if statement to control the selection. However, the complexity of such a program increases dramatically when the number of alternatives increases. The program becomes difficult to read and follow. At times, it may confuse even the person who designed it. Fortunately for us, C has a built-in multi-way decision statement known as a switch. The switch statement tests the value of a given variable or expression against a list of case values. And when a match is found, a block of statements associated with that case is executed. The general form of the switch statement is as shown here. So as you can see in this general form diagram, the expression is an integer expression or characters. Value 1, value 2 are constants of constant expressions and are known as case levels. Each of these values should be unique within a switch statement. Block 1, block 2, etc. are statement lists and may contain 0 or more statements. There is no need to put braces around these blocks. Note that case levels end with a colon, as you can see here. When the switch is executed, the value of the expression is successfully compared against the values value 1, value 2, etc. If a case is found whose value matches with the value of the expression, then the block of statements that follows the case are executed. The break statement at the end of each block signals the end of a particular case and causes an exit from the switch statement, transferring the control to the statement X following the switch. And finally, the default here is an optional case. When present, it will be executed if the value of the expression does not match with any of the case values. If not present, no action takes place if all matches fail and the control goes to the statement X. In C, we can use as many as 257 case levels. So let us check a flowchart of the switch statement as well. Here you can see we have the entry, then the switch expression, then we have this cases or the expressions which have the value 1, value 2, and finally the default. And then whichever is true, that case will be executed, and if no case is true, then the default case will be executed, and then it will give the control to the statement X. So this is a flowchart defining the selection process of the switch statement. So let us take an example of the switch statement in our editor so that we can understand about the switch statement better. So here you can see I have written a program for a simple calculator using the switch statement. What I am doing is, here you can see I have taken a variable operator which is of the character data type. With the help of this, I will take an input from the user about the type of operation he or she wants to do. It may be addition, subtraction, multiplication, or division. Then I have taken two variables n1 and n2. This will be the operands, and then they are of the floating point data type. Then here you can see this statement will tell the user which type of operation he wants to do. Then here you can see I am taking the type of operator input from the user, and then I am taking this print statement which will tell the user to input the two operands. And then this is the use of the switch, and in the switch you can see this is the operator. The operator will be out of this four: plus, minus, multiplication, and division. And then you can see this is the syntax of writing it. These are the cases. So this will be the four cases. So if it is plus, then it will calculate the addition of n1 and n2, the two numbers, and then it will break. In this case, it will be n1 minus n2 for this negative symbol, which is subtraction. In this case, it will be multiplication, and it will calculate the product, and then it will break. Or else, in this case, it will be division, and it will calculate n1 divided by n2, and then it will break. Or suppose if all these four cases are not true, and the user provides any other character, then it will print the default statement, which is error operator is not correct. So let us run this program so that we can check whether it is working properly or not. I'm pressing F9 and I'm running it. You can see, let the operator be divide, and press enter. It is asking me for the two operands now. Say let me give 20, and then I will give 5 and press enter. You can see it is dividing 20 by 5 here, and it is printing the result, which is 4. So 5 4s are 20. The answer is correct. So it is working right. Let me check it for other values as well. I will again run it. Let me zoom it for you. And if I put plus as the operator and press enter, it is asking me for the two operands. I will give 1 and then I will give 2. So 1 plus 2 should be 3. I am pressing enter. You can see the answer is 3 here. And let me check when I give a character which is not present in these four values, which are this: plus, minus, multiplication, and divide. Let me give any other value. So I will press enter and then I will run it again. And here, let me give the character to be, say, a dot. You can see I've given a dot here. And let me press enter. It's asking me for the operands. Let it be 12 and 13, say, and press enter. You can see it says error operator is not correct. So this is how the switch case is working. Now let me press enter. You can see whenever this four cases are true, then any one of this case will be executed. Otherwise, if I provide an operator which is not present in this four operators, then it will be printing the default statement, which is error operator is not correct. So this is how the switch statement is used in C. So let us move on to the next topic, which is the conditional operator. So what is the conditional operator? The C language has an unusual operator useful for making two-way decisions. This operator is a combination of question mark and colon and takes three operands. This operator is popularly known as the conditional operator or the ternary operator. The general form of use of the conditional operator is as follows: conditional expression, comma, question mark, expression 1, colon, expression 2. The conditional expression is evaluated first. If the result is non-zero or true, expression 1 is evaluated and is returned as the value of the conditional expression. Otherwise, expression 2 is evaluated and its value is returned. For example, let us go on to the editor so that we can check an example and know the proper use of the conditional operator. So here you can see I am using this syntax of the conditional operator here in this program code. What I am trying to do is I am taking a user input of the age of the user. So if the age of the user is less than 18, he or she is not eligible to vote. If it is more than 18, he or she is eligible to vote. That's what I'm trying to print in this program. So I'm taking the variable age, which is integer. Then I'm telling the user to print his or her age. Then I'm using the conditional operator here, and you can see this is the condition: age greater than equal to 18. If this is true, then it will print eligible for voting. If this statement is not true, it will print not eligible for voting. So let me run it so that you can understand and have a better idea. I'll press F9 and let me just zoom it for you. Enter your age, it says. I will give 5 and press enter. Now you can see it says not eligible for voting. So I'll press enter again and let me run it and show you the other way around. So here again, let me zoom it for you and let me show you by writing say 19 and press enter. Now you can see it says the other way around. It says eligible for voting because this is equal to or more than 18. So this program is working perfectly. So this is a way of using the conditional operator in C language. So now let us go on to the next topic, which is the Goto statement. So far, we have discussed ways of controlling the flow of execution based on certain specific conditions. Like many other languages, C supports the Goto statement to branch unconditionally from one point to another in the program. Although it may not be essential to use the Goto statement in a highly structured language like C, there may be occasions when the use of Goto might be desirable. The Goto requires a label in order to identify the place where the branch is to be made. A label is any valid variable name and must be followed by a colon. This is very important. We have to follow a label by a colon. The label is placed immediately before the statement where the control is to be transferred. The general form of Goto and label statements are shown here. You can see there are two forms, which are the forward jump and the backward jump. Here the label can be anywhere in the program, either before or after the Goto label. Note that a Goto breaks the normal sequential execution of the program. So in normal sequential execution, it will be executed step by step. But when you use the Goto statement, it breaks the normal sequence. If the label is before the statement Goto label, a loop will be formed and some statements will be executed repeatedly. Such a jump is known as the backward jump, as you can see in the picture. On the other hand, if the label is placed after the Goto label, some statements will be skipped and the jump is known as a forward jump. A Goto is often used at the end of a program to direct the control to go to the input statement to read further data. So let us take an example where you will be understanding more about the Goto statement. So here I am in my editor and you can see I have used the Goto statement here and also here you can see. So what I am trying to do here is I have taken two variables x and y and I am trying to calculate the square root of this x variable and store it in this y variable. Therefore, I have taken these two variables of the floating data type. Then this is the label read, and then I am trying to take the user data for this x, and then I'm checking if the value of x is less than 0, then I'm telling the control of the program to go to this read level again, and if it is more than 0, then it will come to this line and it will calculate the square root. And you should keep in mind that this square root function is not available in the standard input output library. Therefore, you have to include the math.h library also for this square root function to work. And finally, after calculating this square root, I'm printing this x value, also the square root value, which is y. And finally, you can see I'm again using the Goto, and what it will do is it will again go to this read level, which is here. So this will create a problem in the program. I want to actually show that problem to you. It will go into an infinite loop and it will not be controllable. So let me run it for you so that you can understand. I'm pressing F9, and here you can see it's waiting for me to provide a data. So I have to provide the data for x. Let me provide 3 here and press enter. Let me zoom it first. Here you can see I have provided 3 and then press enter. You can see this is the value of 3 or x. As you can see here, this is x. So I'm getting the square root, which is y. This is the square root of x, which is 3. Now it's not ending this loop, it is waiting. So if I provide any other data, so 2 and press enter, it is calculating the square root for 2 as well. Then if I provide say 3 and press enter, again it is calculating, but it is not going out of this loop. So to terminate this, you can use the keyboard interrupt, which is Control and C. But you can see sometimes it doesn't work. It is copying or again repeating the same code. You can see if I press Ctrl C, it is again doing the same thing. So in that case, what you can do is you can manually close this program by clicking on this close button. So this is not a good way of using the Goto statement, because here I'm using the Goto here, it is going to this read label, and finally after the execution of this statement also I'm using the Goto. So I will delete this line, I will delete it. Then if I show you how to use it, you will find the proper way of using the Goto. I will press F9. Now if I run this, you can see it's asking me for the input. I'm giving 3 and pressing enter. So here you see this is the value of x3 and this is the square root 1.732051, and now it is going out of the program code. So now if I press enter, you have got to know the proper use of this Goto. With the help of this, we can go to this read label, because if the value of x is less than 0, I don't want to calculate the square root because it will not be possible. Therefore, what I am trying to do is I am checking the value of x to be positive, and then I am continuing to this statement. If it is not greater than 0, I am telling the program control to go to this read level again. So this is how to do it. And I will show you another example where you will understand more about the Goto statement. Let me show it to you. So here you can see I have taken two variables x and y of the floating data type. Then I am taking a count variable which is integer data type, and I am initializing the value of count to 1. And then I am telling the user to print 5 real values in a line. Then I am putting a label read, and then what I am doing is I am taking user input of the 5 real values. So that we are not confused, I have put a /n here so that the control will go to the next line. And here what I am doing is, if I find that the value of x is less than 0, then I am telling that the value is negative, and then I am showing the value of count as well. You can see here. Then if the value of x is more than 0, it will go to this else block and it will calculate the square root, and here it will print the value of x and also the value of y, which is the square root, and then it will increment the value of count to 1. So this will only be possible if the else block is true, then only it will increment the value of count to 1. And you can see finally I have given an if statement. If the value of count is less than or equal to 5, then it will go to this read level, and finally when this entire code is done and the value of count becomes equal to or greater than 5, then it will go out and it will print end of computation. So what I am doing is I am taking 5 real values and then I am calculating the square root and displaying the output. When the count is more than 5, it will go out and it will print end of computation. Let me run it so that you can understand what is actually happening. I'll press F9 and then you can see enter 5 real values in a line. First, let me give only one value, say 2, and press enter. You can see it's giving me the value of 2 and the square root as well. I will press 3 and press enter. It gave me the result for the value 3 as well. Then I will press 5 and press enter. It gave the result for 5 as well. But it is continuing because you can see this Goto is going to this read level here again and again, this read level. So as long as the count is not satisfied, it will keep on going to the read level again and again. So what I will do is I will provide the next one, which is 9, say, and press enter, and it is giving the result. So you can see there are 4 values given, 2, 3, 5 and 9, and now I will give the 5th value, which is say 7, and press enter. Now you can see the count has increased to 5, and this condition, if count less than equal to 5, it becomes equal to 5 in this case. Therefore it prints the next print statement, which is end of computation, and it is finishing the process. So this is how you can properly use the Goto statement. Here, with the help of this Goto statement, we are going to this level read and taking more input from the user as long as the count value is not equal to 5. So this is how you can do it. We will be talking about decision making and looping statements in C. So before starting the video, I would like to request you people to please like our videos and share it with your friends and family, and also subscribe to our channel and press the bell icon so that you get notifications about our latest updates. Thank you. So let's start with today's topic. In looping, a sequence of statements are executed until some conditions for termination of the loop are satisfied. A program loop therefore consists of 2 segments, one known as the body of the loop and the other known as the control statement. The control statement tests certain conditions and then directs the repeated execution of the statements contained in the body of the loop. So depending on the position of the control statement in the loop, a control structure may be classified either as the entry controlled loop or as the exit controlled loop. The flowcharts here will give you a better idea of entry control loops or exit control loops. So as you can see, in the entry control loop, the control conditions are tested before the start of the loop execution. If the conditions are not satisfied, then the body of the loop will not be executed. In the case of an exit control loop, the test is performed at the end of the body of the loop, and therefore the body is executed unconditionally for the first time. The entry control loop and the exit control loop are also known as pre-test and post-test loops respectively. You have to keep in mind that the test conditions should be carefully stated in order to perform the desired number of loop executions. It is assumed that the test conditions will eventually transfer the control out of the loop. In case, due to some reason, it does not do so, the control sets up an infinite loop and the body is executed over and over again, which is a bad practice. So, a looping process in general would include the following 4 steps. The first step is setting and initialization of a condition variable. Then the second step is execution of the statements in the loop. The third one is test for a specific value of the condition variable for execution of the loop. The fourth one is incrementing or updating the condition variable. So these are the 4 steps which are included in our looping process. So the test may be either to determine whether the loop has been repeated the specified number of times or to determine whether a particular condition has been met. In C language, there are 3 constructs for performing looping operations. They are the while statement, the do while statement, and the for statement. We shall discuss the features and applications of each of these statements in our today's video. So let's start with the while statement. The simplest of all the looping structures in C is the while statement. The basic format of the while statement is, as you can see in the picture, while test condition, then body of the loop. So the while is an entry controlled loop statement. The test condition is evaluated, and if the condition is true, then the body of the loop is executed. After execution of the body, the test condition is once again evaluated, and if it is true, the body is executed once again. This process of repeated execution of the body continues until the test condition finally becomes false and the control is transferred out of the loop. On exit, the program continues with the statement immediately after the body of the loop. So the body of the loop may have one or more statements. The braces are needed only if the body contains 2 or more statements. However, it is a good practice to use braces even if the body has only one statement. Otherwise, we might get confused. So it is better to use braces. So let us go on to the editor and look at an example to know more about the while loop. So here this is my editor, and you can see I have already written an example of the while loop for you. So let me explain it line by line. We have included the standard input output header file, and then this is my main function, and just because it is returning integer values, so I'm using return 0. If you use void, then you don't have to use this return 0 statement. Now you can see that I have initialized a value or a variable a, which is of the integer data type, to the value 20, and then I am checking with the while loop. You can see what I am doing is, till the value of a is less than 30, I am printing the value of a, and then inside the while loop I am incrementing the value of a using a++. So what I am trying to do is, I am trying to print the values of a from 20 till it is less than 30. So in this case, it should print from 20 till 29. As soon as the value becomes 30, it will go out of the condition of the while loop. So let me just provide one enter here so that it becomes good to understand. Okay, now I will run it for you and show you what the output will be looking like. So here you can see, let me just zoom it for you. I initialize the value to 20, you can see here. Then I gave the condition, which is while a less than 30, you can see here. So it's printing the values of a from 20 till, you can see, 29. All these are printed, and as soon as the value of a becomes 30, it will go out of the control of the while loop. So this is a basic example of how to use the while loop. So here what is happening is I initialized a to 20, then I use the while loop, and this is the condition a less than 30. So till the value of a is less than 30, it will be printing the values of a as you saw in the console, and it will be doing it one step at a time. So it was 20, it will be incremented, it will become 21, then it will be displayed, and following till 29 it will be displayed, and then it will go out of the while loop. So this is the basic example. Let me show you the output once again. So here you can see from 20 till 29 has been displayed, and then it came out of the control of the while loop. So now let us move on to the next looping statement, which is the do statement or the do while statement. So the while loop construct that we have discussed in the previous example makes a test of condition before the loop is executed. Therefore, the body of the loop may not be executed at all if the condition is not satisfied at the very first attempt. On some occasions, it might be necessary to execute the body of the loop before the test is performed. In such situations, we can do it with the help of the do statement. The form for the do statement can be as shown in the figure. You can see here do, then body of the loop, then while with the test condition. So what happens here is on reaching the do statement, the program proceeds to evaluate the body of the loop first. Then at the end of the loop, the test condition in the while statement is evaluated. If the condition is true, the program continues to evaluate the body of the loop once again. This process continues as long as the condition is true. When the condition becomes false, the loop will be terminated and the control goes to the statement that appears immediately after the while statement. So since the test condition is evaluated at the bottom of the loop, the do while construct provides an exit controlled loop, and therefore the body of the loop is always executed at least once. So this is the basic difference between the while and the do while loops. In the while loop, only if the condition is true, then the body will be evaluated or executed. In the do statement, the body of the loop is always executed at least for one time. So let us go on to our editor and check an example of the do while statement. So here you can see this is my editor and I have this example for you. So here what I have done is I have taken a number num, and this belongs to the int data type, and I have initialized it to 1. You can see here I have given a comment initializing the variable, and then I am starting the do while loop. What it will do is it will print the multiplication of that number with 2, and it will print the multiplication at least once. Then what I am doing is I am incrementing the value of the variable num by using this plus plus method, and after that you can see the while statement occurs, and here I am checking with the condition num less than equal to 10. So what will happen is from 1 till 10 will be checked, and then it will provide the multiplication output. So in this case, in this do while case, what will happen? It will at least execute the body of the loop once. So let us check the output of this program code. I will be running it now, and you can see, let me zoom it for you. You can see I am getting the answers 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. So when the value of num is 1, then I am getting 2 into 1, which is 2. And similarly till 2 into 10 it is printing, then it is going out of the control of the do while loop. So let me just make certain changes with the program so that I can show you what actually is happening here. Let me take this to be say 11. So now you can see that it is not satisfying this condition, which is num less than equal to 10, because 11 is not less than or equal to 10. But still, even though I have given the value to be 11, it will at least execute this loop once. So let me run it now. You can see it's at least executing the body of the loop one time. So 11 into 2 will be 22. So this is the output for that. And after that, while it is going to this while loop, it is taking the condition, and since it is not true, it is going out of the control of the loop. So this is the difference between while and do while. In the do while, the body will be executed at least once. Then it will go out of the control of the while loop if it does not satisfy the condition. So now let us move on to the next topic, which is the for statement. So let us first talk about simple for loops. The for loop is another entry control loop that provides a more concise loop control structure. The general form for the for loop is, as you can see in the picture, for initialization, then the test condition, then increment, or it may be decrement depending on our choice. Then we have the body of the loop. Now let me tell you the execution of the for statement. First, initialization of the control variables is done using assignment statements such as I equal to 1 and count equal to 0. Then the variables I and count are known as loop control variables. The second step is the value of the control variable is tested using the test condition. The test condition is a relational expression such as I less than 10 that determines when the loop will exit. So if the test condition is true, then it will either increment or decrement it, and then it will be executing the body of the loop. And then the third step comes. After executing the body of the loop, it will go to the beginning of the for loop, and then it will again check the condition. If it satisfies, then it will go inside the body of the loop, and then in the fourth step it will be continuing the same process over and over again as long as the condition is true. Then in the fifth step it will go out of the condition of the loop if the condition does not satisfy or it is finished. Then in the last step it will go to the next statement. So let us check an example in the editor so that you can understand about the simple for loops in a better way. So here in my editor you can see that I have written a certain program which will print the numbers from 1 to 10, and I will show you what I have actually done here. This is my main function. Let me press an enter, and now you can see I have initialized a variable int I. You have to remember in this case that whichever loop variables you are taking, you have to initialize those variables, because otherwise your program will encounter errors. So this loop variable has to be initialized. Just because it is an integer value, therefore I have initialized it to the integer data type. And now I am using my for loop, and here you can see the condition is the assignment operator, which is I equal to 1. Then I am checking with this condition I less than 11. Then I am incrementing like this, plus plus I, or you can write I plus plus. So what happens is it will print the value of I as long as this condition is true. It should be less than 11. So in this case it will be printing from 1 till 10. Then after that it will go out of the body of the for loop, because as soon as it becomes 11 it will not execute this body, it will go out. So let me run it for you so that you can check the output. Here you can see I am getting the values 1 till 10 displayed here. So this is what this program is doing. And finally when the value of I becomes 11, it will go out of the body of the for loop. So this is a basic example of the for loop. Now let us move on to the next topic. Nesting of for loops or nested for loops. So nesting of loops, that is one for statement with another for statement, is allowed in C. And the nesting may continue up to any desired level. The loops should be properly indented so as to enable the reader to easily determine which statements are contained within each for statement. In C programming, it allows up to 15 levels of nesting. However, some common compilers permit more nestings of for loops. So, let us move on to our editor so that we can check an example to know better about the nested for loops. So here in my editor, I have written a program to print a multiplication table. So you can see I have used nested for loops here. You can see this is one for loop, and inside this for loop I have another for loop, as you can see here in red highlighted text. So let me show you what actually is happening with the table. I have initialized three variables n, I and j. So this I and j are the loop variables, and n is the certain number for which I want the multiplication tables to be displayed in my console. So you can see all these are integer data types, so I have initialized them to the integer data type, and here I am asking the user to print the number for which they want the multiplication table to be displayed. Then with the help of the scanf statement here, I am taking the value of n from the user, and finally to display the n tables, suppose up to 10, what I am doing is I am using the for loop. This for loop is known as the outer loop, and this loop is known as the inner loop. There can be many numbers of nested loops. As I told you, normally C programming allows up to 15 nested for loops, and some other compilers allow more than that. So first what will happen is it will take the numbers from 1, then it will increment the numbers till the value of n which the user will provide. Suppose the user provides 5, then the multiplication table from 1 till 5 will be displayed, and I want to display 10 multiples here. So 1 ones are 1 till 1 tens are 10 will be displayed. Similarly, from 5 ones are 5 till 5 tens are 50 will be displayed. So the highest multiple is till 10 times. Therefore, I have taken this inner loop. You can see here, it takes the value till 10. So j less than equal to 10 has been taken here. So what will happen is the outside for loop or the outer for loop will take the values from 1 till the value of n provided by the user, and for the inner for loop it will calculate the multiplication from 1 till 10 multiples, and then it will be printing the value of that multiplication table, and as soon as the value reaches equal to the value provided by the user, it will print the multiplication table, and then it will go out of the control of the for loop. And here I have used one printf statement where I have taken a escape character /n so that I get the multiplication tables one line after the other, so that the output looks good. Now let me run this program for you so that I can show you the multiplication table. So here you can see I am pressing 5 and then pressing enter, and you can see the multiplication table from 1 till 5 have been displayed here. You can see the 1 table, the 2 table, and similarly till the 5 multiplication table has been displayed here. So you can provide any other number also, it will provide you the multiplication table till that number. So this is how the nested for loop is working here, and in this way you can do many other operations using the nested for loops. Okay, now let us move on to our next topics, where we will learn about using the break and the continue statements. The break and the continue statements come under the section jumps in loops. So, loops perform a set of operations repeatedly until the control variable fails to satisfy the test condition. The number of times a loop is repeated is decided in advance and the test condition is written to achieve this. Sometimes when executing a loop, it becomes desirable to skip a part of the loop or to leave the loop as soon as a certain condition occurs. For example, consider the case of searching for a particular name in a list containing say 100 names. A program loop written for reading and testing the names 100 times must be terminated as soon as the desired name is found. So, C programming permits a jump from one statement to another within a loop as well as a jump out of a loop. So, let us check jumping out of a loop. An early exit from a loop can be accomplished by using the break statement or the goto statement. We have already seen the use of break statement in the switch statement in my earlier videos and the goto in the if-else construct. These statements can also be used within while, do or for loops. So when a break statement is encountered inside a loop, the loop is immediately exited and the program continues with the statement immediately following the loop. So whenever the loops are nested, the break would only exit from the loop containing it. That is, the break will exit only a single loop. So let us check the use of the break statement and the continue statements. So here in my editor, you can see I have written a program which calculates the sum of numbers and it calculates the sum of maximum 10 numbers. And what I have done in this is, whenever the user enters a negative number, the loop will terminate. To terminate the loop, I am using the break statement here, as you can see. So let me explain the running of the program line by line. So here you can see, let me press an enter, and then you can see this is my main function, and here I have initialized a variable I, which is actually the loop variable I, to my integer data type. Then I am taking two other variables, one is number and the other one is sum. So these two are of the double data type because the user may provide decimal numbers as well. So here I am initializing my for loop. You can see here, let me press one more enter here so that you don't get confused, and then you can see it takes first value and it goes on till the 10th value. So I am calculating the sum of 10 maximum numbers, and then here you can see the increment operator is used. Then this for loop is actually to take the 10 values from the user. And what happens is, I have used the if statement. You can see if the value of the number provided by the user is less than 1 or it is a negative number, then I am using the break statement. So it will directly go out of the control of this for loop and it will terminate the loop. Otherwise, if the number is positive, then it will calculate the sum, and finally the sum will be displayed here. As you can see, by using of the printf statement, the sum has been displayed. So let me run it so that I can show you what actually happens. Just provide the numbers one by one. So I am providing normal numbers or positive numbers in the first case. I will provide 1, then 2, then 3, then 4, then 5, then 6, then 7, 8, 9, and finally 10. So what happens is I am providing positive numbers. So in this case, the loop is not terminated. It will calculate the value and it will display the sum. Let me press enter. You can see the sum has been displayed, which is 55. Now the program has finished. So let me press enter. And this was the normal case where I provided all positive values. And now I will show you the reaction of the program when I provide negative values. As I told you here, whenever this if statement condition is not true or the number provided by the user is negative, then it will break from this loop. Let me show you what happens. I will run it again, and in this case let me provide 2, then 3, then I will provide -1 and press enter. You can see as soon as I provided -1, it calculates the sum of the earlier two numbers 2 and 3, which is 5, and then it terminated the program because I gave a negative number which did not satisfy this if condition, if number less than 0.0. So here in this case this is not satisfying this condition, or you can say the number here is less than 0, and therefore the break statement has been executed and it is terminating the loop and it is displaying the sum for these two numbers 2 and 3, and then it is finishing the process. So I will press enter again and I will show you one more thing. I'm running it again. Let me provide directly a negative number, say -5, and press enter. So you can see it does not calculate the sum. It simply goes out of the control of the loop. So this is how you can use the break statement. So now I will show you the use of the continue statement and show you the difference. This is the use of the continue statement, and it is a similar program to the earlier program, but here what happens whenever the user provides a negative number. So in this case what happens is whenever the user provides a negative number, it will continue and it will not calculate the value of the negative number, and it will not consider this negative number. It will consider only the positive values and calculate the sum. So this is the use of the continue statement. What happens is it will take all the positive numbers and calculate the addition, but in case the user provides a negative number, it will continue and it will not calculate the sum of that negative number. This continue statement again goes to the control of the beginning of the for loop. So again the user will be prompted to provide a number till the count is 10. So I will show you how this works. Let me run it for you. And now I will show you the difference. Here let me provide 1, 2, 3, and I will give a negative number now, -2, and press enter. So here you can see the difference. When I am giving a negative number, it is not going out of the loop, it is going back to the control of this for loop again here, and then it is asking me to provide a different number. So here I will give 3 and press enter, and then again I will give -9, press enter, and then -5, press enter, say 6, enter, 5, enter, let it be 7, then I will press enter, and you can see it calculates the sum in this case. So let us check it. So 7 plus 5 is 12, 12 plus 6 is 18, then 18 plus 3 is 21, 21 plus 3 is 24, then plus 2 is 26, then plus 1 is 27. So you can see only for the positive values we are getting the sum, and the negative values have been skipped. So this is the use of the continue statement, and as soon as the user provides a negative number, it continues the program execution and it will go to the beginning of the for loop and ask for providing us a different number. So this is how the continue is used. With the help of this continue, the program execution will continue. But in the earlier example, you saw that when you use the break statement, it exits the loop. So this is how you can use the break and the continue statements inside loops. These are called the jumps in loops. So you can jump into a loop or jump out of a loop. We will be talking about finding the roots of a quadratic equation. I will be showing you a C program with the help of which you can find the roots of a quadratic equation. But before starting the video, I would like to request you people to please like and share our videos, and also subscribe to our channel and press the bell icon so that you get notifications about our latest updates. Thank you. So let's get started. So as I said, today I will be showing you how to find the roots of a quadratic equation with the help of a C program. So a general form of a quadratic equation is like this: ax squared plus bx plus c is equal to 0, where a, b and c are the coefficients. So to find the roots of a quadratic equation, first of all, you have to know the formula. The formula is, as you can see on the screen. Before that, we need to know something. We need to find a term so that we can find the roots of a quadratic equation. The term is called the discriminant, which is represented as this: b square minus 4 into a into c. So this term is known as the discriminant, or this expression is known as the discriminant: b square minus 4 into a into c. So there are three conditions depending on which the roots of a quadratic equation can be evaluated. The three conditions are b square minus 4ac, or the discriminant, less than 0, b square minus 4ac equal to 0, and b square minus 4ac greater than 0. So whenever the discriminant is less than 0, the roots are imaginary. And whenever the discriminant is equal to 0, the roots are real and equal. And whenever the discriminant is more than 0, then the roots are real and distinct. So as you can see here, these are the three conditions. Discriminant less than 0 means the roots are imaginary. Discriminant equal to 0 means the roots are real and equal. And discriminant greater than 0 means the roots will be real and distinct. So let us go on to the editor so that I can show you the program with the help of which we will be calculating the roots of the quadratic equation. So here I am on my editor, and you can see I have already written a program for you, and this is the header file math.h, which has to be included in our header files so that we can use the square root function which is included in the math.h header file. You can see here I have used the square root function. So let me show you and explain you the program line by line. Here this is my main function, and here I have taken a double data type and taken these variables, which are a, b, c, then the discriminant, then the root 1, root 2, and if the discriminant is less than 0, then I have also taken the real part and the imaginary part. You can see here. And therefore, I am taking the printf function with the help of which I am telling the user to enter the coefficients of a, b, and c. And then finally, with the help of the scanf function, I am taking the input from the user and storing them in the variables a, b, and c, as you can see here. Then here I am calculating the discriminant, b square minus 4 into a into c. And also I am printing the value of the discriminant with the help of this print function. And now comes the three conditions, as I told you earlier. The condition for real and different roots. As I told you, if the value of discriminant is greater than 0, then the roots will be real and different. And here I am calculating the root 1, which is minus b plus square root of discriminant divided by 2a. And this is the formula for root 2, minus b minus discriminant square root divided by 2a. Then I am printing the roots one by one. Then finally, just because the roots are real and different, I am printing this statement as well. The roots are real and different. And then if this condition is not satisfied, then I am using the else if, where the discriminant value is equal 0. In this case, the roots are real and equal. So the formula is minus b divided by 2 into a for both the roots. Then here I am printing both the roots. And finally, if this condition is not true, then finally the discriminant value will be less than 0. So here what will happen? I will print the real part and the imaginary part, as you can see here. So the real part is minus b divided by 2a, and the imaginary part is the square root of the discriminant and then divide by twice a. Just because it is an imaginary part, you can see that I have taken the minus sign in front of the discriminant. And finally, I am printing the real and the imaginary parts, as you can see here, with the help of these two printf statements. So this is the complete logic behind this program. And now I will run it so that I can show you all the three different conditions where we will be calculating the roots of this quadratic equation. So let me run it for you. So I'm just zooming it for you so that you can see it better. Let us try with the first condition where the value of discriminant is equal to 0. So here I will give the input. Say the value of A is 1, then the value of B is 2, and the value of C is 1. And I will press enter. And you can see here, discriminant is 0, and therefore, as I said, the roots are root 1 equal to root 2 equal to minus 1. So here it prints the roots are real and equal. And now let us go on to check the next condition, which is the roots are imaginary. That is, b square minus 4ac is less than 0. Let me run it again and let me zoom it. And here I will take the value of a to be 1, value of b to be 2, and the value of c to be 3. And then let me press enter. You can see b square minus 4ac is less than 0. Therefore, root 1 is in the form of a plus ib, as you can see here, minus 1 plus 1.41 into I, and root 2 equal to minus 1 minus 1.41 into I, and it prints the roots are imaginary. This is because it satisfies this condition. The value of discriminant is minus 8, which is less than 0. And now let us see the final condition, which is the value of discriminant is greater than 0. Then the roots are real and distinct or unique. Let me run it again. Let me zoom it and let me show you the third output. Let me take the value of a to be minus 1, value of b to be 3, and the value of c to be 6, and press enter. You can see here the discriminant value is positive, and therefore the roots are real and distinct. You can see they are different. Unique roots, root 1 equal to minus 1.37 and root 2 equal to 4.37. Therefore, the roots are real and different. Now, so this way you can calculate the roots of a quadratic equation, where I told you there are three conditions: discriminant equal to 0, less than 0, and greater than 0. When it is equal to 0, the roots are real and equal. When it is less than 0, the roots are imaginary. When it is more than 0 or greater than 0, the roots are real and different. And let me summarize with the formula. The total formula is, as you can see in the screen here, root 1 equal to, or all total, let me show you all total, minus b plus minus square root of b square minus 4ac divided by 2 into a. Out of this, if you have to extract root 1 and root 2, you can write like this: root 1 equal to minus b plus b square minus 4ac square root divided by 2a, and root 2 equal to minus b minus square root of b square minus 4ac divided by 2 into a. So this is how you can calculate the roots of a quadratic equation with the help of a C program. I will be talking about how to compute the binomial coefficients with the help of a C program. So before starting the video, I would like to request you people to please like and share our videos with your friends and family, and also subscribe to our channel Goto Arcade and press the bell icon so that you receive notifications about our latest updates. Thank you. So let's get started. As I told you, to compute the binomial coefficients, we need to first know about a formula of the binomial coefficients. As you can see here, this is the formula for the binomial coefficients. It is NCR is equal to n factorial divided by n minus r factorial into r factorial. Suppose we have taken the values for n and r to be 6 and 4 respectively, then the formula will be like this. NCR is equal to 6C4 is equal to 6 factorial divided by 6 minus 4 factorial into 4 factorial. Then if you calculate the result, you will find that it is 360. So this is the basic formula. As you can see here in the screen, NCR is equal to n factorial divided by n minus r factorial into r factorial. So let us go on to the editor so that I can show you the program with the help of which we can calculate the binomial coefficients. So I'm going to my editor now. And you can see here, I have already written down the program for you. So this is the header file and this is my main file. And you can see I have taken 3 variables which are of the integer data type, and there are 4 variables which are of the long integer data type. Then I have used the printf function and I'm printing this, enter the value of n and r. And then with the help of the scanf function, I am taking the input of the values n and r from the user. Then initially I am taking the values of x, y and z to be 1. Let me tell you, this x is for n factorial, y is for n minus r factorial, and z is for the final one, which is r factorial. So I'm calculating all the values x, y and z individually so that finally I can use the formula NCR and I can use the separate formula, which is n factorial divided by n minus r factorial into r factorial. Therefore, I have individually taken x, y and z, as you can see here. So first of all, I am using a for loop to calculate x. As you can see here, just because n factorial comes in the beginning, I am taking I equal to n, I greater than equal to 1 because it cannot be 0, and then I am decrementing the value of I. So then I'm calculating the value of x, which is x equal to x into I. So it will go in a reverse order just because I'm decrementing it. Suppose it is 4, then it will be like 4 into 3 into 2 into 1. So this is the n factorial part. Now let us go on to the n minus r factorial part. For that, I have taken I value to be n minus r, as you can see here. And then I am decrementing it one by one. So this way it will give the product and it will calculate the values in the reverse order, like 4 into 3 into 2 into 1. It can be any number. It depends on you. So let us now move on to the final one, which is r factorial. So for that I have taken z, as you can see here. So here also I am taking a for loop and then I am doing this operation. And you can see it's decremented, I is minus minus. So it will calculate the multiplication in reverse order. Finally, you can see here, this is the NCR variable, which is of the long data type. And here I am calculating this n factorial divided by n minus r factorial into r factorial. But instead of that, I am taking x, y and z because these 3 variables represent my n factorial, n minus r factorial and r factorial. X represents n factorial, y represents n minus r factorial and z represents r factorial. Then I am using the printf function to print my value of n, value of r and finally the value of my NCR, which is the binomial coefficient. So let me run it for you so that you can check the result. Here, let me zoom it for you. I am taking the value of n to be 4 and the value of r to be 2. And let me press enter. You can see I'm getting the result, which is NCR or 4C2 is equal to 12. Let me take it for the one I told you earlier, which is 6 and 4. And I said the answer is 360. Let me do it for you. I'm taking the value of n to be 6 and the value of r to be 4. And let me do it now. As you can see here, the value of NCR is 360. So this is how you can compute binomial coefficients with the help of a C program. I will be talking about plotting of the Pascal's triangle with the help of a C program. So what is a Pascal's triangle? A Pascal's triangle can be as shown in the figure. Here you can see, depending on the number of rows, we can have a different result. And as you can see here, the first row starts with 1, then followed by 1 and 1, and then the next row will have 1 and 1, and these two ones will be added, and in between we will have a 2. Similarly, in the next row we will have 1, and then 1 and 2 will be added, and then we have 3, and then again 2 and 1 will be added, we have 3, and then finally we have 1 1. So the triangle goes on like this. Depending on the number of rows you have, the value will be added on and it will keep on continuing. So now that you know the idea of how to print this triangle, let us move on to the editor so that I can show you a program with the help of which you can print this Pascal's triangle onto the console or the terminal. So let's move on to the editor. So here you can see I have already written down a program for you to print the Pascal's triangle, and this is the header file followed by my main function, and here you can see this is a variable rows which is of the integer data type. This will have the number of rows, and then I have this variable which is coefficient, and this is initiated to 1, and then I have this space variable which is for the spaces that we will require while we are printing the Pascal's triangle, and I have this I and j as my loop variables in order to provide the spaces. And then I'm using the printf function so that I can print the statement, enter the number of rows, and with the help of the scanf function, I am taking the input of the number of rows from the user and storing it into my rows variable. And then after this, I am again using a printf function so that I can go on to the control in the next line. Now I am going on to the logic inside the program so that I can print the Pascal's triangle. So this for loop, you can see this is the outer for loop, which is for I equal to 0, I less than number of rows I plus plus. And inside this I have one inner for loop where you can see I have initiated the value of the space to be 1. Then this actually is space less than equal to rows minus I. So what happens is it will keep on printing the spaces according to this logic, and finally I am incrementing the space by using this space plus plus. So with the help of this line of code, I am printing the empty spaces. You can see here print empty spaces, and I have given 2 spaces so that I get the desired output of the triangle. And after that, to print the values, as you can see, I have taken the coefficient to be 1, and finally I'm using another for loop where I'm using this conditional operator. You can see this, and I'm checking these conditions j equal to 0 and I equal 0. Then the coefficient will be is equal to 1, because as you saw in the triangle, in the two sides I want ones to be printed, right? Otherwise, I want the values to be added. So to add those values, as you saw, I got 1, then 1, 1, then 1, 2, 1, then I got 1, 3, 3, 1, and so on. What I can do is, you have to remember this formula. The formula is coefficient equal to coefficient into I minus j plus 1 divided by j. So with the help of this formula only, we can implement the Pascal's triangle. Otherwise, it won't be working. So with the help of this formula, we can print the Pascal's triangle. Then after that, I am printing this value, printf percentage 4b. Then I am printing the coefficient, as you can see here. And after that, just because I want the control to go to the next line, I am giving this print statement outside this control of the for loop, so that I can go on to the next line. As you can see here, I've given two slash n's, with the help of which I will be going to the next line. After that, I'm ending my for loop, which was the outer for loop, and finally I'm giving this return 0 statement because I'm returning integer values. And finally, I'm concluding my main function. So this is the program for printing the Pascal's triangle. Now I will run it for you so that you can get an idea of how to print the Pascal's triangle. Let me run it for you. Let me just zoom it. And now let me give the number of rows to be 5 and press enter. So here you can see this is the Pascal triangle. In the sides we have 1 printed, and in the first row it is 1, and in the second row it is 1 and 1, and in the third row you can see this is the 1, and again 1 plus 1 is 2, so we are getting 2 here, and finally again 1. And in the fourth row 1 is at the extremes, and then 1 plus 2 is 3, 2 plus 1 is again 3, then again we get 1. Again in the fifth row we are getting 1, then 1 plus 3 is 4, 3 plus 3 is 6, and then 3 plus 1 is again 4, and then in the extremity we have 1. So depending on the number of rows, you will get the output like this. So let me just press enter, and let me run it once again so that I can show you for more number of rows. Let us take the number of rows to be 8, and let me zoom it, and now I'll press enter, and now you can see depending on the number of rows you provide, you will get a bigger triangle. So this is how you can print the Pascal's triangle with the help of a C program. And in that, you have to remember this formula: coefficient equal to coefficient into I minus j plus 1 divided by j. So with the help of this only, we can implement the other different values that are changing depending on the number of rows. So this is the logic behind printing the Pascal's triangle. So this is all about this video, guys. Thanks for watching. Hope you like the video, and if you like it, then tell us in the comment section below. If you have any doubts, then post them in the comment section. I will definitely try to clear those doubts. Also, like, share and subscribe to our channel Codus Arcade, and press the bell icon so that you will get a notification when we post a new video. Thank you. Happy learning.